Good afternoon all. In the last class we have seen associative memories and its characteristics. In today's class we'll see associative memory model. So as part of that associative memory model, if you see the first diagram, there is an input layer and output layer and connection links. The corresponding connection links have synaptic links and it has some weights, synaptic junction weights. Those junction weights are indicated with some two lines like a capacitor. So there are M input neurons as well as M output neurons. From M input neurons to M output neurons, there are connections and corresponding connection link weights also. The similar thing can be represented in the ANN model in the below diagram. Let us take the first input neuron as XK1 neuron, XK2 neuron, XK3 neuron, and so on. XKM are the input neurons. YK1, YK2, YK3, and so on. YKM are the output neurons. So this model is having some association from XK to YK. That means input is XK, K1, K2, K3, and so on KM. So that's why XK. And output is YK neurons. That is YK1, YK2, YK3, and so on YK. So this kth pattern, let us assume this as some kth pattern input neurons as well as output neurons. That's why the corresponding connection link weights also indicated in bracket with some K. W11K likewise. W11 it represent that subscript. First subscript should represent the output neuron, second subscript should represent the input neuron. W11 means first output subscript. W11, one is nothing but first subscript, another one is nothing but first subscript output, and another one is first input neuron. I think that connection link weights indication we were already discussed. If you see any connection link weights, you can understand that subscript part, two numerals indicates the output and input neurons. Let us take, if you take that example of at XK2 to YK1, connection link weight is W12. W12 means first output neuron to the second input neuron. Connection link weight. That's why we need to represent the first output as a subscript, then input as a subscript. That's why W12 and in bracket K, that is kth pattern connection link weights. Even if you take that from XK2 to YKM, M is the mth neuron to XK2 neuron. That's why the corresponding connection link weight should be YM2 of kth pattern. Like that, the ANN model is represented, and in bracket it is represented with K, means this is with respect to the kth pattern. For this kth pattern, the corresponding connection link weights are indicated like this. For every particular pattern, there are particular set of weights, particular connection link weights will be there. So that will identify the corresponding output. There is an association between the XK, all these are vectors, right? XK1 to XKM vector, YK1 to YKM or is vector. That's why XK arrow to YK arrow. Here XK to YK, there is an association with respect to the corresponding connection link weights. That corresponding connection link weights will identify the corresponding pattern. For example, if we are providing one input input vector, that is xk vector, xk1 to xk2 to and so on xkn. Corresponding to that input vector, we should get one output pattern. The output pattern we are getting with respect to the connection link weights, and that association should come through the memory. We'll see in the next slides how we are getting that association, or how we are getting that output pattern with respect to the input pattern. So just you remember that connection link weight, how we are denoting that connection link weights, what is the input, what is the output, how we are representing that as a vectors. So xk is the input, yk is the output. There are m number of neurons at the input and m number of neurons at the output. Even that can be different number also. M number of neurons at the input, and let us take n number of different number can be at output also, but here I have taken both input and output as m number of neurons. That's why yk1 to ykm and xk1 to xkm number indicated here. So xk is a vector. That vector generally we will get in a vertical fashion, right? But if you do the transpose, it will come in the horizontal. That's why xk1, xk2 and so on xkm transpose. Yk also vector, yk1, yk2 and so on ykm transpose. So it is a basic relation here. This relation itself is enough to understand this associative memory. Ykj, which is nothing but output, right? Here output. We see the second diagram, yk1, yk2 and so on ykm, right? In between, at one particular neuron, I would like to take the output. See the output. That neuron number, here I am assuming that ykj, 1, yk1, yk2, yk3 and so on ykj and so on ykm. So in that we are getting ykj somewhere. So that ykj in box I am indicated that one particular output neuron as ykj. K represent the kth pattern, jth number neuron output. Ykj is equal to, generally output is equal input into corresponding connection link weight. Here corresponding connection link weight W into input is nothing but X. So W, what is the corresponding neuron at the output? Jth neuron. That's why first subscript is J. W, J. And that output neuron is connected, one particular output neuron is connected with all the inputs. That's why W, jth neuron is the first subscript, and second subscript, let it be I, WJI, and I can be vary from I is equal 1 to m, because at the input we are having m number of neurons. All m number of neurons will be connected to that particular jth neuron. All input neurons will be connected to the each and every output neuron, right? So that's why jth neuron is the output, and corresponding input can vary from input neurons are from I is equal 1 to m. In bracket I have mentioned with k. K means that is kth pattern connection link weight into, again, what is the input? xki, because input is, again, at input also if you see the diagram, xk1, xk2 and so on, let us take somewhere you will get xki, then and so on xkm. So from xki means all these xk1, xk2 and so on xkm I am indicated with simply one xki, where I is varying from 1 to m. Now if you see that total equation, ykj is equal to summation I is equal 1 to m wji of k into xki. So here I represent I is equal to 1 to m because at the input m number of neurons are there, J represents the output neuron, jth neuron that is. And here K represents the kth pattern. One particular pattern. For that, if you want to see the output at the, you want to retrieve the output at the jth neuron, the corresponding equation will become like this. If you want to retrieve the corresponding output at the second neuron, means you can substitute J is equal to 2. Then you will get the YK2 output, corresponding output at the second neuron, YK3, YK4. But I have taken simply J, where J also can vary from 1 to M, because at the output also you are having M neurons. So here WKJ is equal to summation can be written as WJ, J from I is equal 1 to M if you substitute, WJ 1 of K, WJ 2 of K, and so on, WJ M of K, XKI, that can be the vector again, XK1, XK2, and so on, XK. It is nothing but second equation. So now here you can vary J also from 1 to M, I also can be varied from 1 to M, because both input and output are M neurons. So with respect to the kth pattern, this is the equation, second equation. But here this YKJ, jth neuron output only indicated in the second equation. If you want to see all the output neuron, all the neurons output at the output layer, so you need to substitute J is equal to 1 to M. Then your equation will become YKJ is there, right? In the second equation, J is equal to 1 to M you can substitute. In the weights also J is there, that also you can substitute 1 to M. Then your equation will become YK1, YK2, YK3, and so on, YK. The corresponding connection link weight, YK1 connection link weights are, if you want to get the YK1 output, the corresponding connection link weights are W11 of K, W12 of K, and so on, W1 of K. First row will be multiplied with the right side, that is XK bar, XK1, XK2, and so on, XK. That XK1, XK2, and so on, XK will not change, because that is kth pattern, M neurons, simply one vertical. Even input also will not change. The corresponding connection link weights will change, and each row represent the one particular input and output association, corresponding association link weights. If you want to see the output, or if you want to retrieve the YK2 output, second neuron kth pattern output, then W21, because there WJI is there, right? I is equal to 1 to M, already we have substituted. Now WKJ, in that J is equal to 2 we need to substitute, J is equal to WK2, then YKJ is there, right? YKJ means J is equal to means YK2 is equal to WJI, right? J is equal to, that's why W21 second row is J is equal to means everywhere first subscript 2 only will get it, but J I, right? I is equal to 1 to M, we need to substitute W21 of K, W22 of K, and so on, W2 M of K. We get the connection link weights, and so on. If J is equal to M means W last row in that square bracket in the equation 3. J is equal to M means YKM, YKJ, J is equal to M, YKM is equal to WM1 of K, WM2 of K, and so on, WMM of K into corresponding input. For example, if you want to see the output, WKM last mth neuron output is equal to WM1 of K into XK1 plus WM2 of K, last row will be multiplied with the corresponding inputs, WM2 of K into XK2 plus w m3 of k into xk3 plus and so on w mm of k into xkm. That is the corresponding ykm output. So this is kth pattern, corresponding connection link weights and output input. Likewise, k means k can also vary. You may have number of patterns. So that's why here xk to yk association equation is nothing but this one. Here k can also vary from 1 to some number that I am assuming here q. K can vary from 1 to q. If it is first pattern means w1 of k can be replaced with the 1. If it is some qth pattern means 1, 2, 3 and so on. Like 3 equation will get q number of equations now based on the number of patterns by substituting k is equal 1 to q. Now your yk bar is equal to wk bar into xk bar. Last but one equation in this slide. Yk bar is equal to w of k bar into xk bar. It represents that the output yk kth pattern output is equal to kth pattern corresponding connection link weight into kth pattern input vector. Let us take, if you want to see the first, if you substitute k is equal to 1, that is nothing but first pattern output. Y1 is equal to w of 1 into x1. Again y w x can be equated to this third equation. Here the corresponding M is nothing but M by M memory matrix, because you are having M number of input neurons, M number of output neurons. That's why your M will be equal to the M by M memory matrix. The third equation, second bracket, square bracket is there, right? That is nothing but M by M matrix. M by M weight matrix, but here weights are indirectly treated as memory. M by M memory matrix. Based on this weights only, the patterns will be identified. You will get the corresponding connection, corresponding output with respect to the memory only. Memory is nothing but indirectly weights. Here the middle square bracket represents the M by M memory matrix. Weight matrix is nothing but memory matrix, where M is equal to M vector, right? All these are vectors. M is equal to summation k is equal 1 to q. Memory is represented with respect to the patterns. How many patterns you need to memorize? K number of patterns are there. M is equal to summation k is equal 1 to q wk, where k can vary from 1 to q. So if it is k is equal 1 means first pattern memory, then M is equal to means second pattern memory. Likewise and so on up to q patterns memory can be collected in that M matrix, where M indicates the total experience gained. Total experience gained means here equation 4 can be rewritten in a recursive form like mk bar, mk vector is equal to mk minus vector plus wk bar. What it represents means, let us substitute k is equal 1. If you substitute k is equal 1, the corresponding equation will become m1 is equal to m1 minus 1, that is m0 plus w0, right? K is equal to 1 means m1 is equal to m1 minus 1 from last third equation. So m1 is equal to m1 minus 1, that is nothing but m0 plus w0. That means, sorry, w1. If you want to know the memory of first pattern, m1, which is nothing but m0 should be added with the present weights m1, w1, right? Present weight matrix. m0 obviously it is 0. Initially there is no memory, so that's why m0 is represented with the 0. If you go for last pattern mq, then it is equal to the total memory. mq is nothing but the total memory m bar. So here how this memory is updating means, if let us take m2, second pattern memory. If you want to a second pattern memory m2, right? Second pattern memory, what it will become means previous memory. What is previous memory? m2 if you are finding out means m1 is the previous memory. That previous memory is nothing but mk minus 1. Previous pattern memory plus current pattern weights, that is nothing but w2. m2 is equal to m1 plus w2. m2 is equal to m1 plus w2 means m2 is the present pattern memory will become or is equal to previous pattern memory plus present pattern connection link weights, that is nothing but w2. There are three terms, right? In the equation mk is equal to mk minus 1 plus wk. In the three terms are there. mk is nothing but present pattern memory. Second term mk minus 1 is nothing but previous pattern memory plus third term is nothing but w of k, present pattern connection link weights. So each pattern will have m by m connection link weights matrix, right? From this equation 3, each pattern, this is kth pattern equation only, equation 3. Likewise k can vary from 1 to q means you will have q number of such equations in a similar way to the 3. So in that case m by m matrix, the connection link weight matrix will be, there are q number of connection link weights m by m matrices because k can vary from q, right? 1 to q, right? So in that case if you want to know the qth, mk is equal to mk minus 1 plus w of k means w of k represents the present pattern connection link weight matrix. Again that is equal to the m by m matrix only, but there is only one particular connection link weight matrix. mk minus 1 represent the previous all pattern. If you are substituting k is equal to 10 means all 9, 10 minus 1, m9 represent all 9 patterns memory is stored in that m9 matrix. By adding this previous memory to the present memory you will get the overall memory. So here when you are trying to provide some input pattern, let us take x1 or x2 or x3 pattern, xk1, xk2 and so on, it is there, right? x11 or x21 or x31, any one particular input pattern if you are providing, it will try to provide the corresponding output yk, xk to yk, right? K can vary from 1 to m, output k also can vary from 1 to q. So based on this connection link weights, for each and every pattern there will be one particular connection link weights. All those are stored into that memory matrix. Then we will get the, if you are providing one particular pattern xk, k can vary from 1 to q. Let us take x2 if you are providing means the corresponding connection link output pattern y2 will be retrieved based on this memory matrix, that is nothing but connection link weights, because already we were provided every pattern with some particular connection link weights. Those are stored in that memory matrix. Indirectly that is nothing but weight matrix. We are not trying to get what are the connection link weights. Connection link weights we are not retrieving, we are trying to retrieve the output only. All these previous memory or previous pattern weights will be added to the present present weights are added to the previous memory and it will be added and so on till the kth pattern. We are not again trying to retrieve that connection link weights, but simply we are trying to get the, our intention is we need to get the output with respect to the xk, we need to get the yk. For that this memory will be used, because already for each pattern there is particular connection link weight matrix. Based on that we will try to, based on this association, this is what called association. Already we were provided some association between the xk to yk. That association we are using it to retrieve that particular data. Like in the last class example, the last class one example I have given, when we see some person, we will try to recollect or remember that person based on that associative memory. Associative memory means indirectly we will try to, it's not directly we can go to that particular person's name, data bank, we're not doing like that, right? Okay, I have seen him in so and so class or in so and so village and he belongs to this particular branch, and he may sit either in the starting or last or left or right, like that. We try to recollect that memory, human brain, how human brain trying to recollect that memory based on that association. Here also in the same way, based on the previous memory mk-1 plus present weights, we are trying to provide the association between the xk to yk. Okay, this is all about the associative memory model. Thank you.